Assalamu alaikum dear researchers and welcome to this video tutorials on PLS-SEM with SmartPLS 4. Today our topic is necessary condition analysis. Recent research in NCA can be traced back to Dull 2016. However, for the sake of this tutorial, I have borrowed most of the material from this Richard 2022 and Richard 2023 paper. So what is necessary condition analysis? Necessary condition analysis is a methodological choice designed to identify and evaluate necessary conditions in a research data. It provides a unique perspective on causality by emphasizing the critical factors that must be in place to achieve a specific outcome. So unlike traditional methods such as regression analysis or PLS-SEM modeling, which operates on sufficiency logic, NCA focuses on necessity logic. So what is this necessity logic? This implies that a particular condition X, for example an IV, is indispensable for achieving an outcome Y. In other words, according to this necessary logic, if X is absent, Y cannot occur. However, the presence of X alone does not guarantee Y. X is a necessary but not sufficient for Y to materialize. So let's take an example of this TAM model or technology adoption model. The perceived usefulness of a technology may be necessary for its adoption. So we can say that perceived usefulness, until or unless the respondents do not think that the technology is useful, they are not going to adopt it. So without usefulness, user will not adopt the technology. What is difference between additive and necessity logic? So actually, traditionally, when theorizing about relationship between two or more variables, researchers refer to different causal logics. Most time they refer to is additive logic. Additive logic assumes that multiple independent variables contribute to the dependent variable's outcome. So each variable has a unique and sufficient impact, and the effect of different variables can compensate for one another. So there can be multiple IVs, and these multiple IVs can we can say that they are affecting or they have influence on the DV. This is mostly used in techniques like regression analysis and partial least square structure equation modeling like PLS-SEM or other SEM techniques. What is in necessity logic? It focuses on conditions that are indispensable or very important for an outcome to occur. That we can say they're necessary for an outcome to occur. A necessary condition must be present for the outcome to exist, but its presence alone does not guarantee the outcome. So this is analyzed using the necessary condition analysis or NCA. What is the difference between both additive and necessity logic? In additive logic, we say that x increases y, or x1, x2, x3, x4 increases y. In necessity logic, we say that x is required for y or a certain level of y, as we will see further. Their average contributions are basically checked for how they impact the y, and in necessity logic, the essential constraints or the factors, the levels of x are seen which affects the y or which are necessary for a certain level of y. In additive logic, there may be other factors which exist to compensate. In necessary logic, we say this is the only factors that if it's not present, the failure is guaranteed or the y is not present over there. So there is a scenario, technology adoption. If we see according to additive logic, we say the more a user perceives the technology as easy to use or usefulness. Now these are two IVs. The higher the likelihood of adoption, either factors alone can contribute to adoption. Now this is called a sufficiency logic. In necessity logic, we can say that perceived usefulness is a necessary condition. For example, after analysis, we find that perceived usefulness is a necessary condition. So we would say that without it, no adoption will occur. However, high is the perceived ease of use, regardless of how easy it is. We will say that if it's not useful or if it is not perceived useful, the intention to use will not exist. So what we can do is that we can integrate the sufficiency or additive logic with the necessity logic. The integration of necessary condition analysis and partial least square equation modeling provides a comprehensive way to assess causality by combining a must-have and should-have perspective. Must-have means necessity, should-have means sufficiency perspective or additive perspective. NCA identifies critical factors that are indispensable for achieving an outcome, while PLS-SEM highlights how various predictors contribute to the outcome. This combined approach addresses limitations inherent in each standalone methods, enhances problematization, and ensures a more thorough understanding of antecedent-outcome relationship. It has gained traction in fields like business research, offering valuable insight for researchers, practitioners, and policymakers by identifying both essential preconditions and contributory influences. Now let's look at this logic. So we have established that a necessary condition basically constitutes a constraint, a bottleneck, or a critical factor that must be overcome or satisfied so that a desired outcome can exist. And we can refer it X is needed for Y, or Y require X, or X is critical for Y. So there can be multiple names that we can give it to this necessary condition. But we need to understand that it can be applied to conditions and outcomes that are measured on different levels. For example, as you can see in this figure on the left hand side, if your variables are dichotomous or binary in nature, so we can say that if the x is present, that over here if x is present, then y will be present. That will be a necessary condition. If x is absent, then y will be absent, y will not be present. So this area over here is this space shows that y is not present when x is not present. So this dichotomous case is the simplest form of necessary condition and refers to necessary in kind, where a condition is either necessary or not for an outcome. However, they can also refer to certain level of conditions or certain level of outcome. For example, instead of assuming that we have binary, we can have low, medium, or high level of x, and low, medium, and high level of y, which is a discrete necessary condition. An example can be given like for political stability is necessary for foreign direct investment. So we can say that a certain level of political stability is necessary for a certain level of foreign direct investment. So we can say over here, if x is high, we can have a high level of outcome. We can have a medium level of y as well. So this is a necessary condition in the case that if we want a medium level of y, we should have either medium level of x or a high level of x. So if we require this level, we need these two conditions to be satisfied. Similarly, this figure on the right hand side shows a continuous example where a certain level of x or xc, as we can see over here, is required for a certain level of yc, as we can see over here. So in all these instances, necessity is indicated by an empty space in the upper left corner of the tables or the scatter plots, as we can see over here. So and NCA, what it does, it that is identifies these empty spaces in the scatter plot to determine the presence of a necessary condition. If we want to look at more specifically, we can say that NCA draws a ceiling line. This basically a ceiling line which separates the spaces without observation from the spaces with observation. This ceiling line determines the level of condition of X that is necessary to reach a certain level of Y. Now there are two types of ceiling lines. Ceiling envelopment line, the one that joins the topmost point in the scatter plot. Now this basically it is abbreviated as CEFTH, ceiling envelopment free disposable hull or disposal hull, and the other line is CRFDH or ceiling regression free disposal hull line. Now this CEFDH or ceiling envelopment line is basically the line that covers the most or the largest empty space above it, and it is actually recommended for a discrete data or the in case when the scatter plot is irregular. In case this ceiling regression line is basically a linear regression to the upper left points of the CEFDH line, and this one is recommended for the continuous data or when the pattern of observation near the ceiling line is approximately linear. Let's take a look at when CRFDH is recommended. CRFDH or the ceiling regression free disposal hull line is recommended for continuous data or when the pattern of observation near the ceiling line is approximately linear or when the theory suggests that ceiling line is straight. CEFDH is recommended for discrete data or when the pattern of observation near the ceiling line is irregular. Here in this figure, we can also see a bottleneck table. This bottleneck table is a tabular representation of the ceiling lines actually. It can be both for CRFDH, it can be both for CEFDH. Now, this bottleneck table represents different levels of outcomes and different levels of inputs or X, that is the dependent variable. Now, these levels can be expressed either as a percentage or can be expressed as a range or it can be expressed as a quartile as well. So here we have another example of a bottleneck table which is more in detail and the one kind of Something the similar you will find in SmartPLS as well. So here we can see for different percentages ranges of y or different levels of y, we have the actual values of y, and then we have actual values of x, and we can have x in counts like as you can see this green line. You can see that if we want to achieve 50% of y, we need to have a level of x3, or in percentile 16.7 percentiles of the value should be above this particular value, or minimum 10 counts of x are required to achieve this value. This n shows says that this is not a necessary condition. For example, no value of x is needed for 30% of y if we want to attain 30% of y. So x is, there is no sufficient condition, or though there is no necessary condition for x at this value. So it starts with the minimum 40% we can achieve with value of x at 3, and then again value of x at 3 we can also achieve 50%, and as the value of x is increasing, the value of y is also increasing. NCA calculates several parameters to assess if a necessity hypothesis is supported. The main parameter is the necessity effect D, which is calculated by dividing the empty space, which is called the ceiling zone, empty space above that line. Like if we have a scatter plot like this, so this empty space is basically the ceiling zone by entire area that includes the observation, which is called the scope. So this is the scope. So greater is the value of D, greater is the effect size. According to Dull 2016, anything that is between 0 and zero point 0.1 is a small effect. Anything that is greater than zero point 0.1 to less than zero point 0.3 is a medium effect. And everything that is greater than zero point 0.3, less than zero point 0.5 is a large effect, and greater than zero point 0.5 is a very large effect. So according to some other research, D greater than zero point 0.1 is the meaningful results, and we should consider that effect size. In addition to the effect size values, we should also check for the significance of the D values using the NCA permutation test. So if the result is significant, we can say the necessity condition exists. Otherwise, we would say the necessity condition does not exist. Now let's see the demonstration of necessary condition analysis, or NCA, using SmartPLS 4. What we are going to do is, first of all, we are going to have a model, a theoretical model. We can go through all the process of measurement model analysis, all the process of structural model analysis. And for NCA, we have to move to the regression analysis. But before doing that, we need to save the latent scores of each IV and each DV, because for the regression analysis, of course, we need the summative or the latent score. So we need a single value against each variable. So how we can get that value is, if we go to calculate and calculate PLS-SEM algorithm, and then start calculation. So here the assumption is that I've gone through all those measurement model parameters, like the reliabilities, the validities, and all those parameters that we can check in the measurement model. Here we can also check all these reliabilities and validities. So where we can find those latent variable score is that on the left hand side you can see there's a latent variable score option here. So what you can do is you can copy this to Excel and save it as a new CSV or Excel file, and then upload it for your SmartPLS project. Here I've already done that, and there is necessary condition analysis. So these LV scores are already saved scores for these particular variables that I just depicted in my demonstration. Attitude, ease of use, intention to use, perceived usefulness. And then we can start a regression analysis. How to start a regression model? Right click, new regression model. So you can start a new regression model. This is a regression model. And now for necessary condition analysis, you go to calculate, and here you will find the option necessary condition analysis, or NCA. So click this button. Now it will ask number of steps for a bottleneck table. Now the literature suggests that although this can be, for example, if you select the value for 10, it the bottleneck table will be divided into 10 steps, or there will be a difference of 10%. But the literature suggests that if your scale is measured on like 5-point Likert scale, these steps should be chosen as either 5 or 4. So the maximum is 5, minimum is 1. So you can choose 5. That's more appropriate. Now start calculation. Now here on the left hand side, you can see there's a bottleneck table. There's a ceiling line effect size overview. The effect size is this range. And as we have already discussed, the range that is greater than zero point 0.2 or greater than zero point 0.3 is basically taken as a medium effect, or a large effect as less than zero point 0.3, and greater than zero point 0.1 is taken as a medium effect, and less than zero point 0.1 is taken as a small effect. So in case attitude and ease of use has a medium effect, and perceived usefulness has a small effect if according to FDH and according to CEFDH and according to CR, like envelopment line and regression line. In both options we can see. But how to select which line we are going to refer to? We can always look at the chart, the NCA ceiling line charts, and we can see that if there is an irregular envelopment line, we can refer to the envelopment line in that case, because in that case the regression line is not a good option to choose from. Similarly, for ease of use, you can see it's irregular, and for perceived usefulness you can also see it's irregular over here. To support the decision on the ceiling line to choose, we can also evaluate the ceiling line accuracy. As you can see in the ceiling line accuracy, the ceiling line accuracy for envelopment line is will always be 100%. So it's not an accurate measure, that it will not be less than 100%. But for CRFDH, the literature says that if accuracy is less than 95%, then definitely you are going to choose CEFDH. But in many cases, if you have seen the charts and you see that it's not a very smooth line for CRFDH, you can go for CEFDH, and most of the literature actually supports to go for CEFDH. So there is no actually bottom line, and there is no clear cut selection criteria. So CEFDH is actually the more accurate measure, or more accurate statistics for NCA. Once you have seen all these results, and you have seen the bottleneck tables as well, this is bottleneck table for CEFDH of different intention to use, values of intention to use, how much value of attitude is required. For instance, we say we need 60% intention to use among our respondents. So the value of attitude should be at least 1.789. The value of ease of use should be at least 1.453543, and there is no minimum value of PU at least for 60%. So for 80% intention to use, we need 4.307 intention to use. That is, attitude required is 3.604, ease of use required is 3.026, and perceived usefulness becomes a necessary condition at least at 80% intention to use. So for 80% intention to use, attitude, ease of use, and perceived usefulness all becomes a necessary condition. We can also see these value in percentiles. So you can see that 5.54 percentile of PU is actually required at least for this value. 80% of intention to use, and similar values for ease of use are mentioned over here. The next step is to calculate the permutation so that we can see the significance of our effect size. So here we run the permutation, and we can see all these D values are actually significant, so we can report them. And with the bottleneck table, we can report the effect size and the bottleneck table both. Let's take a recap for the steps for NCA. First of all, we develop the conceptual model, which include both sufficiency model and necessity model. Collect the data, PLS-SEM analysis for measurement model and evaluation of that measurement model. Then extraction of the latent scores, as I explained that we need latent score because we have to run regression analysis. Then run the necessary condition analysis by starting a regression model. Then choose the ceiling line from the charts and the accuracy depending upon how the data reacts. Which ceiling line are we going for, FTH or CEFDH or CRFDH? And then check the effect size and its significance, the D values and its significance, and then look at the bottleneck table for a minimum value of X that is required for a certain value of Y. Then we evaluate the structural model relationships. We look for the significance of the path coefficients, then predictive relevance, R square, F square values, and explanatory powers. Predictive relevance we can see by CV, PAT, or PLS predict. And explanatory power we can see by R square and F square values, and then we interpret the findings. Now, how to interpret the finding? That is the last part of this tutorial. To understand step number 8, let's take an example from Richard et al. 2023. There are 4 IVs: emotional values, ease of use, usefulness, and compatibility, and adoption intention that is based upon TAM model. Now, remember that this NCA is actually univariate analysis. So each IV is calculated separately. The NCA is calculated separately, although you may see the results uh, in a combined form. There is no effect of one variable on another, like in regression or PLS analysis, in which there is a effect of one variable on another. So if you remove a variable, the score will remain the same. The results will remain the same. So it's a univariate, basically bivariate actually analysis. So how we interpret the results? Now there are two results that we need to understand. First of all, we need to understand that the scenario can be like that we have an exogenous construct that is significant. Significant means the p-value for the path coefficient is significant. Like in the case, emotional value and perceived usefulness is significant, and in parallel, the NC is also significant. The effect size is also significant. So how we can interpret that result? So both emotional values and perceived usefulness are significant predictors as well, and are necessary condition. There is a necessary condition as well. So conclusion is that on average, an increase in exogenous construct will increase the outcome. This is a regression or sufficiency logic. However, a certain level that we can see in the NCA bottleneck table of the exogenous construct is necessary for the outcome to manifest. So interpretation can be on average an increase in emotional value, and the perceived usefulness of a technology will increase its adoption. Also, a technology needs to have a certain minimum level of emotional value and perceived usefulness to be adopted. So both additive logic and sufficiency and necessity logic are actually fulfilled in this case. Exogenous construct is significant but not necessary condition. So it is significant but not necessary. So how we can interpret? On average, an increase in exogenous construct will increase the outcome, but no minimum level of the construct is needed because it's not a necessary condition to ensure that outcome will manifest. Third scenario is that we have a non-significant determinant, but it is a necessary condition. So a certain level of the exogenous construct is necessary for the outcome to manifest, because as we can see in the bottleneck table. However, a further increase is not recommended since it will not increase the outcome any further, because there is no linear relationship in this case, which is not significant. Finally, both are not significant, like there is no significant relationship as of p-value of path coefficient is not significant and not a necessary condition. So uh, a change in the exogenous construct will not significantly influence the outcome. There is no necessary level of the antecedent to ensure that outcome will manifest. So there can be 4 scenarios, and since we have developed that both necessary conditions and sufficiency conditions can be uh, co-integrated in analysis, which will actually support the weaknesses of both analysis and present a more holistic outcome. So that is all about necessary condition analysis. Thank you.